students, welcome to Year 9 Science and Unit 1 on atoms and stuff. We're looking here at video number 5 and giving you just a brief outline of the history of atomic theory. What we're looking here is to build up over the next few videos and also a number of lessons in class our understanding of how historical developments led to the development and change in our understanding of the structure of the atom, and also how those models helped us to predict what was going to happen in chemical reactions. So the first and the most important thing, I guess, is to understand the idea of the atom is a very, very ancient one. In fact, it was Democritus, a Greek philosopher, who first came up with the term atomos, and that was based on the concept of indivisibility, or thinking about the idea that if you have any matter, no matter what it is, and you try and smash it into smaller and smaller and smaller pieces, there will be a point where you can't smash it anymore, where it's reached the smallest it's going to get, and that's what Democritus called atomos, or the atom. We now have an understanding that there are particles within an atom, and a number of different scientific advances, experiments have led us to believe that the idea of an indivisible atom no longer holds, that there are things within the atom, but we're going to look at those as we go through these next couple of videos. What we need to do is to look at the key players that have made a significant contribution to what we understand about atoms, and then to look perhaps at some of the experiments that were carried out that helped to either confirm or to suggest changes based on some conflict with what we already knew about our models. So atomic theory is a great one for trying to get to a sense of the how science progresses in light of empirical or experimental evidence. So we've had a look at Democritus very briefly. He's the Greek philosopher who coined the term atom, and which we still use through to this day. The next significant person was Antoine Lavoisier, who was French, and he found in the late 1700s the relationship between elements and compounds. What he found was that where compounds, or he basically identified compounds as being made up of two or more elements, but where he found that this was the case, he found that they were occurring in fixed ratios. And of course this was very important because we now know things like water, for example, and hydrogen peroxide are both compounds containing hydrogen and oxygen, but the ratio of those compounds is very, very critical to the nature of the substance. A 2-to-1 ratio of hydrogen to oxygen gives us water, but a 1-to-1 ratio gives us hydrogen peroxide. So this was a very important development. But the next and most important scientist that we need to look at is John Dalton, and he was an English scientist, and in 1808, based on a number of experiments that he had carried out with gases, he proposed what was called the atomic theory. And given the time that he lived in, this theory was a pretty good theory, and one which still holds for much of what we know about atoms today. So it included things such as atoms from each element are different from those of other elements, so unique atoms. And in fact, our periodic table is based on the fact that each element has its own unique atom. Chemical compounds are formed when atoms of one element combine with atoms of another in a fixed proportion. So that's basically concurring with the findings of Lavoisier. He also said that the atoms of a given element are identical to each other. So while they're unique from other elements, they are identical to each other. And we do know some slight variations that have been introduced as a result of that. He also said that atoms can't be created or destroyed in chemical reactions. Well, they can't really in chemical reactions, although they can be changed, but we also know that there are nuclear processes that can occur, particularly in unstable nuclei, where an atom can actually change from one to another. But that's a story for a little bit later in this topic. So a couple of the things that Dalton said as part of his atomic theory were spot on, and things that we have built our modern periodic table and much of the experimental work that we do around chemical reactions on today. But there have been a number of changes and refinements to Dalton's models, and the fact that they aren't the simplest form of chemical nature and that they are themselves constructed of smaller subunits is something that happened as a result of the work of many of the other scientists that are listed on this page. Now we're going to take Thomson, Rutherford and Bohr separately. I'm going to put one little video together on each of these. So the other person that we do need to have a quick look at the moment is James Chadwick, and Chadwick's major contribution was the identification of the neutron. Now this was a particularly difficult thing because the neutron has no charge. And whilst we can look at the interaction between positively charged protons found in the nucleus or negatively charged electrons orbiting the atom, that's more difficult to determine when you aren't looking at a particle that is interacting with electrical magnetic fields, which is the case with the neutron. So Chadwick's work was no less significant than these others, but it just helped to fill in some of the gaps in our knowledge around the concentration of mass within the nucleus of an atom. So what we want to do is to build up a little timeline and an understanding of how empirical evidence, experimental evidence, may have conflicted with our with a certain model that we had that was accepted of the atom, and how that model was changed or developed or redesigned in such a way as to take into account all this new evidence. So we'll be having a look at that in subsequent videos. Thanks for watching.